A group automorphism is an isomorphism from a group to itself. If J is a finite multiplicative group, an automorphism of J can be described as a way of rewriting its multiplication table without altering its pattern of repeated elements. For example, the multiplication table of the group of fourth root of unity J1 negative 1 I negative I can be written as shown above, which means that the map defined by 1 is to 1, negative 1 is to negative 1, I is to negative I, and negative I is to I is an automorphism of J. The map f of x is equal to nx is also a group automorphism. For z over p, z as long as n is not congruent to 0, conjugating by a fixed element h is a group automorphism called an inner automorphism. In general, the automorphism group of an algebraic object circle, like a ring or field, is the set of isomorphism of that object circle and is denoted O2 circle. It forms a group by composition of maps. For a fixed group J, the collection of group automorphisms, the automorphism group Aut J. Let's proceed to homomorphism. Recall that if J and H are groups, an isomorphism Fj is to H is a bijection Fj is to H such that for all J sub 1, J sub 2 element of the group, Fj sub 1, J sub 2 is equal to Fj sub 1 times Fj sub 2. There are many situations where we are given a function Fj sub H which is not necessarily a bijection, but such that f still satisfies the functional equation fj sub 1 j sub 2 is equal to fj sub 1 times fj sub 2. We make this as a definition. Let J and H be a groups. A homomorphism fj is to h is a function fj is to h such that for all j sub 1 j sub 2 element of the group, f is j sub 1 j sub 2 is equal to fj sub 1 times fj sub 2. There are many well-known examples of homomorphism. First, every isomorphism is a homomorphism. Second, if H is a subgroup of a group J and I, H is to J is the inclusion. Then I is a homomorphism, which is essentially the statement that the group operation for H are induced by those for J. Note that I is always injective, but it is surjective. H is to equal to J. Third, the function Fj is to H defined by Fj equals 1. For all J element of the group is a homomorphism, the trivial homomorphism. Note that if F is not injective, if J is not the trivial group, and it is not surjective if H is not the trivial group. Lastly, we talk about isomorphism. Isomorphism is a very general concept that appears in several areas of mathematics. The word derives from the Greek isom meaning equal and morphosis meaning to form or to shape. Formally, an isomorphism is bijective morphism. Informally, an isomorphism is a map that preserves sets and relations among elements. A is isomorphic to B is written A congruent B. Unfortunately, this symbol is also used to denote geometric congruence. An isomorphism from a set of elements onto itself is called an automorphism. So again, thank you for taking time to watch my video. I hope that you will be able to learn what is automorphism, homomorphism, and isomorphism. Again, thank you.